So this is what we're kind of familiar with, degrees. And you shouldn't be, but you are, because it's what most people use. They just randomly took a full revolution. Let's just divide it into 360 parts. Now there must be some reason, I just off the top of my head, I'm not sure what it is. And then like from here to here, we'll just call that 360, but you guys just kind of take it for granted. The funny thing is, you don't even need to do math to know what this stuff means. You need to be 9 years old and be on a skateboard. And the language just comes out, right, at the skate park. Because you know what a 180 is, you know what a 360 is, snowboarding, same thing, right? And then you get to like Shaun White territory and you're doing 1080s, and they know exactly what that means. How many revolutions is that? Well, this is not actually as correct as what you should be doing, which is radians. Because you do know that a circumference is given by this formula. This is proven to be exact. It actually makes sense. I don't know where that comes from. Okay? Now, if this circle, again, pi is one of these cool numbers that, if you look at this poster on the wall, before we had computers, the first guy who calculated it, well, he just named it after a Greek letter, it wasn't named after him, but he got it reasonably accurate. And it didn't just work for that circle, it worked for this one, it worked for this one, and so on, all these different circles. So he's trying to come up with his magic number. And one guy decided, well, I think I want to build on what this guy did, okay, because I've got some spare time. It took him 17 years to calculate it more exactly. 17 years of his life to get more digits to this thing that we call pi, that, you know, kids in elementary think it stops right there. We now know it's an irrational number. But if this is just 1 for a radius, then what do I have? It's 2 pi. That's also the way around this circle. 360 degrees is equal to 2 pi. And that's what we're going to use to convert things back and forth, okay, without using our calculator at first. So what is a radian? 1 radian is this angle if this arc length is equal to the radius. That's it. Okay? If this length as a curve is the same as this length, then we call that angle a radian. Okay, that's what we're going to use to convert it. So converting degrees into radians, if I know 2 pi is 360, I can just make that a little bit nicer. How do I get rid of that 2? Divide it away. So pi is 180 degrees. But better said, pi radians is 180 degrees. Okay? There's a unit here, and it's usually not even written down. So, I know that is 2 pi. Okay? It's 3, sorry? 3.14 radians is 180 degrees. Yeah. Okay? This is in radians. So that, again, that's 360 degrees. It's also equal to 2 pi. So I guess we got a column here. We can put these things over here. So 180, well, that one's easy, right? Ba-doop, ba-doop, ba-doo. That's just equal to pi radians. So let's write it. Again, we become kind of lazy when we teach this and we don't really write it. So 90 degrees then is, it's what? As a fraction of 360. Yeah, 90, 90, and 90, and 90. That's my pizza if I divide it in 4. Well, you know each one of these is 90 degrees. Right? Okay, and of course, that's 90 degrees. So if I know that 360 is 2 pi, then 2 pi over 4 is pi over 2. Or if you see a little pattern happening here, I just divided by 2, didn't I? You know 180 is half of 360. You know 90 is half of 180. But we don't know that half of pi radians is pi over 2 radians. Okay, so it's something we got to kind of get familiar with. 45 degrees, any guesses? Okay, that's 4. That's an eighth of 360. Right? 45 and 45 and 45 and 45. 1, 2, 3, 4, 5, 6, 7, 8 pieces of pizza. That's usually how we cut it, isn't it? 45-degree piece of pizza. Okay, so I've got 2 pi, and I want to take an eighth of that. Well, do we see the pattern? That's pi over 4 radians. Okay, 45 degrees is the same as pi over 4. This one, you can think of it as a third of 90, but let's just go back to 360. How many 30 degrees goes in there? And I got this a little bit backwards, but anyway. That's 12 sections, right? Okay, so I want 2 pi over 12, which is pi over 6. Rads. You remember grade 11? These were called special angles. And I said, try to stick them in your noodle as far as what ratios they were. So the only one that was missing here is the complementary of 30, which is 60 degrees. So for an example, how do we convert it if it's not something nice like that? So if you have something in degrees, you're going to times it by, I want to cancel out degrees. So the only way I'm going to cancel that is if it's on the top and the bottom. That's what you do. You times it by pi over 180. And then you get something in radians, okay? Because the degrees cancels out. So from radians to degrees, guess what? It's the same thing. Just flip it the other way around. Radians divides by radians. Sometimes it's not there. And we're left with something in degrees, right? So that's not a formula per se. It's just the knowledge of there's 2 pi radians, 360 degrees, same thing. So, for example, the one we don't have, special triangle, 60 degrees. I want to convert that to radians. So what do? Well, you've all taken physics, right? It's the same kind of thing. Or chemistry, converting. So I want to put degrees down there so it cancels out. Up here I got pi radians, but I'm not writing it. And this one, we don't want to do a calculator. Okay, some of them are going to be nice. We want actually this as fractions. How many times does 6 go into 18? Okay, so 60 degrees is a third of pi radians, or pi over 3 radians as we normally say it. Should be twice a 30, shouldn't it? And it is, right? So what does that mean exactly? What is pi over 3 radians? Where's my pi button again? Over there. You can just put that in your calculator. That's what it means. 1.047 radians, right? But we don't want to write it like that because that is not exact. It's an approximation. Right? So 60 degrees, what does it mean again pictorially? We know it kind of looks like there's 45, there's 60 degrees. Does that look like 1.047 times as long as that? Yeah, sure, exactly, right? Bang on. Okay, that's graphically, that's what it means. Okay, convert into radians. 100 degrees. What's my little conversion factor? Just pi over 180, because those are equivalent. Okay, and let's leave it as something exact. No calc. Okay? No cheating, Maurice. So cross off a 0, that's 10/18. And what goes in here, what goes in there? 5. Half of that is 9 pi. And like I said, sometimes we don't even write that there. Okay, we get kind of lazy, but that's what it means. 5/9 pi radians. That's what 100 degrees is. How about 720? Cross off a 0. What goes in here? What goes in there? 9 goes in there 2 times. Does 9 go in 72? Does 2 go into 8? Did I need to do all that? Probably not, because you know 360 degrees is 2 pi. So 360 and 360 is 720. So it should be 2 pi and 2 pi. That's 2 full revolutions, right? Either way. Get 4 pi. Okay, how about convert into degrees? Pi over 6. What factor do I want to use here? Conversion factor. Same one, only I want to turn it upside down. Okay, I want to cancel out radians and put this into degrees. So pi cancels out. That's why you don't want to make it a decimal. And 6 goes into 180. 30 degrees. Right? Have we seen that before? Yeah. Two and a third pi radians. How many degrees is that? Well, you probably want to make that an improper fraction, right? 3 times 2 is 6 plus 1. That's 7/3 pi. Then multiply it by my conversion factor. Pi cancels out. And does 3 go into 180? Yep, 60 times. So what's 7 times 60? And then you look at it and say, does it make sense? How many degrees is 2 pi? 360. It's got to be more than 360. It's 2 and a third pi, right? So it is. 360 and 60, or 2 pi and a third pi, and that's 360, and that's 60, if you got all these things memorized, which is 420. Okay, so that's about it. Converting it back and forth. There is a formula to actually get the arc length A if we know the radius r and the angle theta. There's the formula. You just have to remember that angle is not in degrees. That's an angle in radians. So if you give you an angle in degrees and say what's the arc length or what's the radius, you have to convert it to radians first. So we just have one example here. I'll say something else though too, because I looked at the assignment already. A heavy mass is attached to a string that is 15 centimeters in length. M for mass. It sweeps out an arc of 5 centimeters. So that's an arc. Let's emphasize it. And yeah, we did questions like this in Math 11, but it was just an approximation, right? Because we had to assume that was a straight line to do a triangle stuff, like sine law and cosine law. And of course we know that's not actually true, but we didn't know how to do this. So now you do. A is r theta. I want to know what is that angle in radians. So solving that for theta, it's just A over r. Arc length is 5. Radius is 15, which is 1/3 radians. Or 1/3 of a radian, I guess. Sounds better, right? So is that something that looks sense to us? Makes sense to us? Looks sense? It looks sensey? What are we expecting? See, we know degrees. We don't know radians. You have no idea what that thing is. Can we check to see if that's a reasonable answer? What is that in degrees? 1/3. To change that into degrees. Right? And that's going to be 60 over pi, which is 19 degrees. Look reasonable? Given these lengths? I didn't even draw that appropriately, but yeah, it doesn't look that bad, right? That should be 1/3 of that. Seem reasonable? Sure. Okay? So, most of us are visual. How many degrees is that? 1 radian. What does it look like? Bigger than, that's pretty good, 90. Bigger than 45-ish, less than 45-ish? How can we find out? Okay, so 1 rad would be what? What is 180 divided by pi? Just over 57 degrees. Okay? So that's what a radian is. Approximately 57 degrees. Sometimes that's helpful, because if you look at your answer and it says 3 radians, you're thinking, okay, about 160-ish degrees. Does it look reasonable or not? Finally, what's not in here, but they do ask you one question in the assignment. Angular velocity. So, if you got a car and it's got a wheel on it, if the car is moving at some speed v, does that mean that's the speed of the wheel? No. Exactly. So don't worry about it too much, but as a formula, angular velocity, it's not a W, it's an omega. Come on. It's just V over R, okay? Sounds really, really stupidly easy. Okay, don't ask me why. I'm not deriving it. I just noticed it's a question in the assignment. That's all you got to do, okay? That would be angular velocity in radians per second. Okay, so it's there. Pretty simple if you know that, all right? Angular velocity. Greek letter omega. Okay? Well, there's capital and there's lowercase.
Oh, I understand.
Yeah.